Hello and welcome to this network education video. My name is Russell DeLong and this is IMS and Voice over LTE. Now, I am covering this material because for one thing it is in high demand right now and I get emails fairly often requesting that I cover it. Also, I think there's a lack of approachable material covering Voice over LTE as an introduction other than 3GPP white papers themselves, which are quite dry and very unapproachable in my opinion. And I think that I can at least do better than what is out there, or at least do better than what I've seen out there so far. Having said that, I have been reluctant to step into this area because my knowledge of it is mainly theoretical. I've done the legwork on my own in terms of reading up on the theoretical side of IMS and VoLTE, but I can't bring the kind of practical operations experience in IMS that I can in everything else that I've covered in these videos so far. With the EPC, with SS7, with IP networking, I've been in those trenches, so to speak, and I can say when a textbook or the theory is a bit far away from the reality. But for IMS, I can really only speak on the theory and not too much more than that. So I am making this video because I haven't found anything better, and I think, and I make it in the hope that either someone else will take up that torch, so to speak, or that later on I will end up making something that's closer to what the industry really needs on this topic. So the high-level concept, actually I should go back here. So this video seeks to cover a breakdown of the various nodes involved in IMS for VoLTE and a deconstruction of telephony services, expanding it into IMS functions. I'm going to start with the very high-level concept of what the IMS network is or needs to be, and then I'm going to take what we're looking at right here, these red, yellow, and blue squares, and I'm going to break them down into their more basic functions. So you're going to see a whole lot more red, yellow, and blue by the end of these slides as I go through them here. At a high level, VoLTE as a service, you have the Evolved Packet System, or the EPS, which if you're watching my existing videos, you should already know a fair bit about. Evolved Packet System, for IMS, it exists as just one example of an access network that gets the user IP connectivity to the IMS network. And that is all that the EPS is really doing here. When we talk about voice over LTE, most of the new stuff is the voice part. The LTE part is really just the Evolved Packet System and, of course, the EU-TRAN LTE radio that we're talking about when we use the term LTE. But exists only to get us access to the IMS network. Now within the IMS network, you have the very commonly used paradigm within 3GPP of control and user plane. This SIP server is what a user would register with. If he wants to set up a call, he would send the call request to this SIP server, and the SIP server would set up the call with the media component, this media gateway concept, for voice service out to, in this example, the PSTN. Now, this SIP server can be thought of as the equivalent of the telephone switch in a traditional circuit switch network, like serving MSC in the mobile context, and the media gateway would just be the typical media gateway function that is common in virtually any voice network to speak of. So the first thing to cover, I mentioned it earlier, is that the EPS exists as just one example of an IP access network by which a user can reach the IMS network. In concept, you could have IMS services over a Wi-Fi hotspot, you could have IMS services over a cable modem service, over a DSL service from your service provider. As long as a user, a SIP-speaking user client like a phone, can get access, IP connectivity to the IMS network, effectively you can get IMS services. So EPS is just one example of an IP access network. In IMS terminology, you'll hear these referred to as IP CANs, or IP carrier access networks. The EPS is an example of an IP CAN, if you're sort of mapping the terminology of IMS to the terminology of EPS. The next slide here, and you're seeing how I'm just beginning to break this SIP server down and deconstruct it into its base components. Here you have the concept of SIP proxies sitting in front of the different IP access networks. You would do this for a few reasons. One would be you want to control where users are coming from. if you wanted to have different types of services available to different locations, if you wanted to have different types of or different charging models, let's say, based on where a subscriber is located, you don't want to just trust the location identifiers and even the user identifiers of a user coming off of an access network hitting your SIP server with a SIP request. In concept, if you could craft the right SIP message off of the user's phone in a roaming scenario to have him hit your SIP server as being part of your home network, well, SIP itself, the SIP server, just getting a request from a user, you need some mechanism to control those kinds of pieces of information from the user. And one easy way to do that is just to have the user, rather than talking directly to the SIP server, talk to a proxy that is anchoring a given IP access network. And that's where these proxy functions start to come into play. The next part, and I'm adding two things to this slide here. One is an interrogator, and one is the home subscriber server. So if you have more than one SIP server, just as if you had more than one serving MSCs, and you need to figure out, if you're one of these proxies, if you get a SIP registration request from this user coming into the SIP proxy, this SIP proxy needs to figure out, is this subscriber already registered with a SIP server? And even if he isn't, what SIP server should I send this request to if he's trying to register with a SIP server? The user doesn't register with the proxy, he registers with this SIP server, and the proxy just gets him there. So the proxy needs to figure out what SIP server to reach. And he does that by querying indirectly the home subscriber server, the HSS. So I'm not going to cover the actual call flows in this video, but when the subscriber registers with the IMS network, this SIP server is going to send a registration request, a registration notice to the HSS. So the HSS always knows what SIP server a subscriber is registered on. And a subscriber, even if he's simultaneously accessing multiple IP access networks, which he could, a subscriber should always be registered on the same SIP server, or the SIP registrar, if you're familiar with that terminology. So the proxy needs to get the information from the HSS as to what SIP server to send the registration to, but you don't necessarily, and I should point out this is technically optional, you don't necessarily want all these SIP proxies being able to directly hit your home subscriber server. HSS speaks diameter, and you would need diameter connectivity between these servers and your HSS if you wanted to go that route. But what ends up being the case, and what is technically optional, as I said, is having an interrogator sitting in front of the HSS. So rather than forwarding that registration to the SIP server, the SIP proxy could send this to an interrogator. The interrogator has the job of querying the HSS to figure out what SIP server to route this registration request to. He would then route the registration to that SIP server. And then what would eventually end up happening is, for subsequent SIP dialogues, you would have the SIP proxy directly talking to the SIP server. So in order to kind of protect or limit the scope of what can hit the HSS for diameter, you can have this interrogator in front, and that's kind of where this comes in. It is a SIP speaking entity, so it's SIP to SIP to SIP. All of this is SIP except for this HSS interaction here, and that's where that comes into play. And I mentioned authentication. Just as the HSS is used in the Evolve packet system to authenticate a subscriber, well, in a Vaulty scenario, and really in an IMS scenario, the HSS is used for that purpose as well. There's a few different supported authentication models, and one is actually AKA, which is the same as the authentication model of the Evolve packet system. Another thing to note here too, as I'm kind of playing with these colors a bit, the HSS, you can view it as an Evolve packet system node. If you go back to this high-level diagram, the HSS is right here. It's part of the Evolve packet system. It's how users authenticate on the EPS. But the HSS has its origins really in the IMS. IMS predates the Evolve packet system in terms of standards, and the HSS predates the EPS. So HSS is being, I shouldn't say reused in IMS, but it's being used again or already in the IMS to authenticate subscribers. So the next part, to start with, the IMS network was never intended to be limited to voice service. It was intended to be multimedia services reachable by users to this service facilitating network. IMS itself is not a service. It is a service facilitator. It gets users access to different SIP applications. One example application would be telephony service. So this SIP server, the only difference between this diagram and the one previous, I know I'm kind of moving the blocks around a little bit for the illustrations that are coming up, but this SIP server, I've just kind of removed the telephone brain from it. If you want to think of this as a switch, or a telephone switch, I've kind of removed the telephony part and brought it over as an application server. So this SIP server is still registering subscriber. He's still controlling sessions, so he's going to set up, maintain, and tear down subscriber sessions to application servers, to, for example, a telephone server to set up and tear down voice calls. But we've kind of separated the brain of telephony as being an application server and the SIP registration process and maintaining user registrations as being part of this, what we're kind of generically referring to here as the SIP server. So I've kind of split it up a little bit more, and I have this app server. You will hear a couple terms here with the app server. You'll hear the term TAS, Telephony Application Server, which speaks specifically to telephony. You'll also hear MMTEL, Multimedia and Telephony Application Server. That is the broader 3GPP defined application server that can serve telephony as well as other multimedia functions. Now, this architecture leaves it open to have any application server really here. Not just telephony. You could have some video service, you could have some conferencing service, you could have literally any kind of SIP application service that needs media, and you could have it just sort of added into this IMS network as an application server. A lot of times when you're talking about the IMS in smaller parts, the application servers would not be considered part of the, quote, IMS core. It would be the parts that facilitate services to IMS that would really be part of core IMS. Okay, so the next division here, and I'll go back here because I've added a fair bit. I'm taking this media gateway part at the bottom, this yellow, and we're saying, well, yes, we have a SIP server and we have media gateway, this control and user plane part, but we have kind of different requirements here and different levels. So we need to be able to talk to the PSTN, of course, but we also need to be able to talk to other SIP networks. And the way that we would do that might be a bit different. The requirements of the SIP server to talk to the PSTN, well, if you're going to talk to the PSTN, you can't talk SIP, you have to talk something like ISUP. So if you're talking to an IMS network or another SIP network, you don't need to talk ISUP. You don't need to interwork between or translate from one signaling protocol to another. So where the requirements to reach one network are a bit different than another, they've kind of broken them down into separate functions. So the SIP server, again, the parts of the brain of the SIP server are being removed. The control part that needs to know how to talk to other IMS networks is being removed from the SIP server and brought down into this control component controlling the media gateway. And over here we have the PSTN speaking control function, again split out of the SIP server and brought down as its own logical function to control the gateway component towards the PSTN as opposed to the gateway component towards other IMS networks. You also see here the SIP proxy. You're going to see an access control and access gateway concept being applied here on the access side. So users getting to the SIP server, there might be certain types of control that you want to apply to SIP messages from the user towards the SIP server that wouldn't necessarily apply to SIP messages towards an IMS network, that wouldn't necessarily apply to SIP messages towards the PSTN. So where all three of these control elements, that is the access control, the SIP IMS control, sorry, I'm terrible with the mouse here. The SIP IMS control and the PSTN control, where all three of these can be a little bit different in what they would need to do. In true 3GPP fashion, it's been deconstructed as separate individual functions, and they've been given different acronyms. But it's really the same concept over and over again. If you go back to this telephony application slide, it's really just a control and a gateway component reaching some destination voice network. And here we've just broken them down into three different kind of types of networks: the access network, other IMS networks, and the PSTN. Or I say PSTN, but it really could be even another circuit switch network, really something other than a SIP network, something that needs to talk legacy telephony signaling, and we've broken them down into those three components. Now, I debated with myself over at what point in this presentation to transition us from the kind of English words that I'm using to describe things and the formal 3GPP terminology, and I decided this will be kind of a good slide to transition us here. So this next slide is going to be exactly the same as this slide, except I've renamed the boxes to be the 3GPP terms for those boxes. And it's not too bad here. It's a bit of alphabet soup if you've never heard these terms before, but IBCF and Transit Gateway, these are the control and user plane functions towards other IMS networks, or really other SIP networks in general. MGCF is the control element that can talk out to circuit switch networks. MGCF is significant because it's an interworking function. It's able to talk SIP, it's able to talk ISUP, it's able to talk other signaling protocols. And then you've got the ATCF, the access side control element in the access gateway. And here you've got S and P and I CSCFs, that's call session control function. So the SCSCF, that's your SIP registrar. That's what I was referring to all this time as the SIP server and how I've been taking things out of it. The PCSCF is just the proxy server that we've been talking about. And the I is the interrogator that we've been talking about. And just for simplicity, I removed the other two IP carrier access networks. I did that actually here. So if you go from this slide to this slide, one thing I did is just to simplify the diagram, I just said the EPS rather than drawing the other two IP cans as examples. But it'd be the same thing if this was some other IP can. So I know this is a lot of alphabet soup, but we're now moving into the next diagram where I added 3 more things. So I've added DNS and enum, I've added the MRF, and I've added the BGCF. Now the BGCF, I'm going to talk about that first. That's this red here. Anything that's red is what used to be the SIP server that I've kind of removed pieces from. The BGCF, Border Gateway Control Function, this is where the 3GPP, in my view, went a little bit out there. So this is basically a translations table. So the serving CSCF needs to make a decision when it sees a destination number and it gets a request and it needs to forward a SIP invite, let's say, either to another IMS network or it needs to send it to a circuit switch network. It needs to make a basic routing decision about where to route that SIP message. And rather than just define that as something that the serving CSCF needs to do, the 3GPP decided to make it a function called the BGCF. And all the BGCF does is make a simple decision over, do I route this way or do I route that way? In concept, it's a routing table, or a B table, you could almost say, in a sense. And it decides which one of these control elements to forward a call request to. That's it. Now, you will sometimes see lines between the BGCF and IBCF and BGCF and MGCF. Yes, just for the simplicity of the diagram, I just drew it as being off of the serving CSCF. I cannot imagine any scenario, by the way, where you would ever have a standalone BGCF as a box or as a thing that you would ever use. It's basically just a part of the serving CSCF. I've never, ever seen or can't even imagine anyone who would want it to be anything other than that. The MRF, if you caught the coloring code here, the MRF is actually 2 things. It's a gateway and a control function. I didn't want to draw it here because it's often drawn as just MRF, actually. MRF deals with things like call conferencing. Basically, it's an RTP mixer, if you're familiar with that concept. If you need to have multiple endpoints in a single call where one person talks and 5 other people hear it, anything like that, that calls in the MRF function. MRF can be broken down into the MRFP, or the processor, and the MRFC. The MRFC would be the control part. The MRFP would be the user plane gateway part. You can also have lines here between MMTEL and MRF, or other application servers, I should say, in MRF, if you need to invoke that kind of call scenario. So if you had a telephone call being set up on the MMTEL, this telephone application, if it needed some kind of call conferencing functionality, it can actually invoke the MRF in that call flow. So you can see interfaces there between those two. Again, just for the simplicity of the diagram, trying to avoid drawing too many lines, but that is there. Finally, DNS and enum in this slide. DNS, it kind of answers a lot of questions that you might be begging if you're asking, like, how does the PCSCF get the IP address of this, or how does the ICSCF get the IP address of this? Basically, the DNS is kind of the glue that holds a lot of the IMS network together, as is the case, frankly, in the EPS. Gateway selection functions are completely dependent on DNS in the Evolved Packet System, and in the same way, resolving the IP addresses of one or more serving CSCFs or ICSCFs, the DNS service is used for that. Enum is a kind of a separate thing. Enum can be thought of in a way as local number portability. It's similar in that sense. So if you need to route a call to some destination network, if you need to figure out if this is an IMS subscriber or not, you could do a query from the serving CSCF to an enum database, and the enum database would return the SIP URI. In SIP, you always need to resolve a SIP URI to an IP address, and you need ultimately need to get a SIP URI before you can forward anything. And in DNS, it allows you to kind of translate, for example, a telephone number to a tel URI, which is a type of SIP URI that kind of maps to a telephone number. The idea will be if you get an answer to that enum query for the tel URI, then okay, he's a SIP subscriber. If you don't, then you could say, okay, he's not a SIP subscriber, so he needs to go to an MGCF, for example, because he might be a circuit switch subscriber. That's the idea. Alright, the next slide, I am adding in here the PCRF, Policy Control Rules function. PCRF kind of has an interesting place here in VoLTE in the sense that he's not part of the IMS network, and he's arguably not even really part of the Evolved Packet System. You're going to see here that I broke out the P-Gateway. Of course, the P-Gateway is part of the Evolved Packet System. I just, for the sake of simplicity, to say what it is in the EPS that's breaking out. It's the P-Gateway and the Policy Control Enforcement function of the P-Gateway. But PCRF really falls within the Technical Specification 32 series in 3GPP. He's not really, he kind of predates EPS. He's not really, I find it hard to call him part of the Evolved Packet System. He has an interface into the Evolved Packet System called GX. He also has an interface into the IMS network called RX. He kind of stands on his own as kind of a policy controller. He only really applies to the EPS as well. When we're talking about different IP cans, he can apply to other IP cans in concept if 3GPP defines it, but he doesn't necessarily apply to all the different IP cans, all the IP access networks that are getting to IMS. But here, all he's doing is basically setting up bearers. If you're familiar with the EPS bearer concept, he'd be setting up dedicated bearers when SIP invites would indicate that a call is being set up. So creating and tearing down voice calls would translate to the creating and tearing down of dedicated voice bearers, and that would be controlled by the PCRF. So for example, call comes in, the proxy CSCF is going to tell the PCRF is going to say, hey, we got to set up a dedicated bearer here, and the EPS would follow suit as dictated by the PCRF. So buzzwords that I'm not covering, the thing is, IMS is such a huge topic that if I started talking about really any of these in any level of detail, we could just go forever. So I have to sort of stop somewhere. What I'm trying to do in this video is just give a high-level sense of the scope of what IMS really is. I don't want to go into too much of individual pieces. But SRVCC is one. That's 3GPPTS 23.216 goes over it. That deals with continuing calls. If you had an IMS subscriber make a voice call and they moved from an LTE coverage area to an area that had other, like let's say your legacy radio network, and you want to continue that call, SRVCC is kind of lays out the procedures and how to do continuous calls from IMS to circuit switch. ICS, IMS Centralized Services, TS 23.292. ICS is more of a concept than it is a technology, honestly. It's more the idea of getting IMS services if you are not in the LTE network. So if you're in a legacy network, getting access to the IMS core for IMS services, that's kind of what ICS deals with at a high level. Really getting IMS services to any of your subscribers. That's the idea behind ICS. It does, of course, define some interfaces and call flows and procedures to accomplish that, but ICS itself is a concept. It doesn't specifically tie you to one exact call flow or technology. CSFB, Circuit Switch Fallback. Circuit Switch Fallback isn't really IMS. It's almost kind of an alternative to VoLTE or IMS-based voice service. Circuit Switch Fallback is just the idea of a subscriber in an LTE network who is registered on the legacy circuit switch network kind of indirectly, so that if incoming calls come in, the legacy circuit switch network can kind of signal to the EPS to say, hey, incoming call, can you tell the subscriber to fall back onto a legacy voice net or legacy radio access network where he's reachable to receive that call. So circuit switch fallback can be used in place of IMS to have the devices go fall back to legacy networks in order to make and take calls. That's the idea. IN in voice over LTE, you'll hear this, I don't think it's a 3GPP term, but several different operator or vendors will refer to it as next generation IN. The idea here is we're moving away from legacy voice signaling protocols, and that includes things like INAP and CAMEL, things that have been used for call session control for years. So the next generation IN, and that again, not a specific technology, but more of a concept, just deals with getting access to IN services in the context of voice over LTE. You can do that through interworking with legacy CAMEL services or INAP. You can also do that, I guess you could say the newer way is with SIP application servers that give you IN services as opposed to CAMEL. Diameter routing implications. Realistically, I think I'm going to have to cover diameter as its own video. Diameter is a huge topic, and there are a whole bunch of diameter interfaces coming in with IMS, not just for access to the HSS, but also policy control and charging, which I mentioned immediately after. PCC and charging implications, how you charge for this new voice service, realizing that it's over your existing EPS. There's a whole bunch of things that come into play with charging. And policy control I touched on a bit with the PCRF. Roaming actually becomes very interesting because you bring in the potential for PCRF to PCRF interaction. This is a big topic. Enum is a big topic. I talked about it a little bit. Interworking, and I gave an example interworking TS29-163. Basically, where VoLTE has very different and new approaches to how to make voice services happen, and you need to work with existing legacy voice, there's a whole bunch of areas where interworking can come into play. That spec deals with ISUP to SIP interworking, but there's interworking in a whole bunch of different areas that need to be looked at kind of in their own light. This is a big topic in terms of working with existing legacy network for VoLTE. Emergency calling I haven't even touched on, but there's actually another type of CSCF called an E or emergency CSCF, and an EATF as well. I didn't really talk about emergency calling, but there's a bunch of different standards that cover emergency calling for voice over LTE. And device and SIM implications. A new application on the SIM, there's sort of a separation of USIM and iSIM, and devices need to support a whole new signaling protocol. It's not just the traditional NAS messaging anymore. There is that for the EPS, but there's also SIP, and SIP requests, SIP invites, SIP registrations, and all the call handling procedures that come into play when you're a SIP speaking user agent. So roaming, I did want to talk about this very briefly here. There's kind of two very different roaming models. The top one is the traditional LTE roaming, where you have this S8 interface between an S gateway and a P gateway, and you've got your S6A interface between the MME and the HSS, where if you are an operator A subscriber, and this is operator A in green, and operator B is in red. If you're operator B, you basically have the access network, the MME, and the S gateway, and if you're operator A, you have everything else. Now, the model which I think is likely to become more popular is the one at the bottom, and this is loosely referred to as IMS roaming as opposed to LTE roaming. Here you have the operator B's entire evolved packet system. I mean, it's always going to be your HSS, but the EPS here, this is all red. It's the operator B's P gateway, right? Which is a little bit different than the traditional LTE roaming model where you always home to your own P gateway, sort of like an SGSN to GGSN context in GPRS. Well, here it's you're breaking out locally at your visited network's P gateway from the EPS towards a destination IP network, the destination PDN being an IMS network. Here you have operator B's proxy CSCF, and here's where we were talking earlier about how proxies can potentially be untrusted proxies and untrusted networks that you need control. Well, here this IP CAN is another operator's EPS and another operator's proxy CSCF. Here you have an MW interface between their proxy CSCF and your interrogator and your serving CSCF. So you have here your trust boundaries, let's say, are here and here. You also, as I mentioned earlier about PCRFs, you have interaction now between PCRFs. That's an S9 interface between PCRFs, where a call coming in might be signaled here, and you might want to be able to dictate QoS for your subscriber and have this kind of an interaction for policy and rules between PCRFs. So this is an interesting piece. Now, you might be asking, well, why would we do all of this? Why can't we just use the traditional LTE roaming? And the reason is you can use the traditional LTE roaming, but you have to consider this media part and this media part and what the advantages are in this lower model versus the upper model. If you are breaking out at your own P gateway, and this is a user in some other country in the world who's roaming on some other operator's access network, you would be potentially sending your user voice traffic across to your media, your P gateway, which could potentially be very far away. So I think it's really going to depend on how far away this S8 interface is, because of course with voice service you have delay and jitter requirements that are much stricter than data services, where you would want to have fairly close proximity between S and P gateway for this top roaming model, where in this bottom roaming model, if you're breaking out locally at a P gateway within the visited network, that media can potentially be broken out very, very close to where the user is, as opposed to in the top model. And that's kind of what I think is going to dictate between those two roaming models which one becomes more prevalent, but it's still kind of an unknown. Finally, I wanted to end this video with this diagram from 3GPP TS 23.228. This is the first diagram of IMS that I ever saw, and it covers basically everything that we talked about already. But as a starting point, this is a huge amount to walk into. Very, very complicated, a whole bunch of interfaces, so many optionals. The call flows become very, very difficult. If you've ever seen end-to-end VoLTE call flows, they are big and complicated. But again, as anything that is big and complicated, if you break it up into base parts, it becomes much more manageable. And this was the starting point. And I think it's many people's starting points with IMS, and I think this is kind of wrong. We need better introduction type material for people going into IMS, both for people coming from the SIP world or the enterprise voice world into IMS, and people coming from the circuit switch telephony world into IMS. Is a huge amount of theory, a huge amount of material to cover, but I find it can be a bit overwhelming for people as they enter into the IMS world when they see a diagram as big as this, realizing, I mean, some of these functions, the BGCF I mentioned, we're talking about atoms here in terms of very, very small, minimal functions, but it's alphabet soup and hard to walk into. That's all I wanted to cover in this video. So we went over just a taste of a lot of different topics. I'm moving pretty quickly, I know. Some of which I'll probably make dedicated videos on later. Diameter for sure, I know I have to eventually. I hope that I've done at least a better intro than I had to go through with directly reading 3GPP TS 23.228 and onwards. I hope I've saved some people from that pain. But as always, let me know if you have any questions or suggestions on what else you'd like to see here, and thank you very much for